Section 10.3 is on geometric sequences and series. The nth term of a geometric sequence is a sub n equals a sub 1 times r raised to the power of n minus 1, where a sub n is the nth term, a sub 1 is the first term, r is the common ratio, and n is the number of terms. Recall that the common ratio is what each successive term is multiplied by. Let's take a look at some examples here. So this first one says find a sub n for the geometric sequence. And we're given some information here. We know that the first term, a sub 1, is 2/9. We know that r, our common ratio, is 3. And we know that there are 7 terms in this sequence. So let's use our formula. A sub n equals a sub 1 times r to the n minus 1. And let's just plug in our numbers. So a sub 1 is 2/9 times 3 to the 7 minus 1 power, or 2/9 times 3 to the 6th power. Recall that we're going to be evaluating our exponents first before we multiply, or 2/9 times 729, or 162. So what that means is that the 7th term of this geometric sequence is 162. Let's take a look at another example here. Write an equation for the nth term of each of the following geometric sequences. So for the first one, we have 1/3, 2/9, and 4/27. So we're going to use our formula a sub n equals a sub 1 times r to the n minus 1 power. And looking at this, I know that a sub 1, my first term, is 1/3, but I need to find my common ratio. So to find my common ratio, I take the second term and divide it by the first term. In other words, what do I have to multiply 1/3 times to get 2/9? So 2/9 divided by 1/3 is the same as 2/9 times 3/1, or 2/3. So my common ratio is 2/3. So plugging those into the formula, a sub n is equal to 1/3 times 2/3 raised to the power of n minus 1. Notice that I don't multiply the 1/3 and the 2/3 because when I go to plug in a value for n, what I'm going to do is do n minus 1 and raise 2/3 to that power and then multiply it by 1/3. So use the parentheses to distinguish between those two numbers. Here's another example. Let's write an equation for this. So we're given that a sub 3 is equal to 8. So the third term in the sequence is 8, and the common ratio is 2. 1/2. But what we don't know is we don't know what a sub 1 is. And we need that for our formula because remember our formula is this. Okay, so I have r. N is going to be my variable, but I need to figure out what a sub 1 is. I can use this formula to figure out what a sub 1 is. So when n equals, so if a sub 3 is 8, that means when n is 3, a sub n is 8. So I can use that in my formula. So a sub n is 8, and that's equal to a sub 1 times my common ratio, which is 1/2, raised to the power of 3 minus 1. Or 8 is equal to a sub 1 times 1/2. I'm going to put parentheses around it, squared. Or 8 is equal to 1/2 squared is 1/4. 1/4 of a sub 1, and multiplying both sides by 4, I get that a sub 1 equals 32. Now I can just plug that into this formula to get my answer. So the nth term is going to be equal to 32 times my common ratio, which is 1/2, raised to the power of n to the 1. the geometric means. The geometric means is the terms between two non-consecutive terms of a geometric sequence, rather similar to what we saw with the arithmetic means. So this example says find the geometric means, find three geometric means between 3.12 and 49.92. So what that means is I have 3.12 and then I have three numbers that I need to find in between there. Okay, now I don't know what the common ratio is, but I do know a couple things. I do know that a sub 1, my first term, is 3.12. I do know that n is 5. I have 5 terms in this sequence. And I know that a sub n, my nth term, is a sub 5, the fifth term, which is 49.92. But I don't know my common ratio, but I can figure that out. So let's use our formula. A sub n equals a sub 1 times r to the n minus 1. So for n equals 5, a sub 5 is 49.92, and that equals a sub 1. Oh, sorry, I have a sub 1. 3.12 times r, which is what I don't know, to the 5 minus 1, or r to the fourth. So I'm going to divide both sides by 3.12, and that gives me 16 is equal to r to the fourth power. And then taking the fourth root of both sides, I get that r is equal to either a positive or a negative 2, because positive 2 to the fourth power is 16. Negative 2 raised to the fourth power is also 16. So what that means is that I'm going to multiply 3.12 times 2, and that gives me 6.24. Multiplying that by 2, I get 12.84, and multiplying that by 2, I get 24.96, and if I multiply that by 2, I get 49.92. Now, if I'm multiplying by a negative 2, which is another option, I'm going to get a negative 6.24 times negative 2 gives me a positive 12.48, times negative 2 gives me a negative 24.96. So in this case, I actually have two possible answers because r can be either a positive 2 or a negative 2. And as we saw with arithmetic sequences, we can also do a series. We can also do a geometric series, and that is the sum of the terms of a geometric sequence. And we have a couple formulas for this. So the sum of the first n terms of a geometric sequence is s sub n equals a sub 1 times the quantity 1 minus r to the n over 1 minus r, where r cannot be equal to 1, obviously, because that would make your denominator 0. That formula is useful if we know a sub 1 and n, or we can use this formula here. S sub n equals a sub 1 minus a sub n times r over 1 minus r, where r is not equal to 1, and that's useful if we're given a sub 1 and a sub n. So let's take a look at a couple examples that use this. Here we need to find the sum of each geometric series. So we're given that a sub 1 is 2, n is 10, and r is 3. So I'm going to use my first formula, which says s sub n is equal to a sub 1 times the quantity 1 minus r to the n over 1 minus r. So I just need to plug the numbers in. S sub n equals 2 times 1 minus 3 to the 10th power over 1 minus 2. Oops, sorry, r, 1 minus 3. Okay, now grab your calculator. That's going to give me 2 times 1 minus 3 to the 10th power is 59,049 divided by negative 2. And when I do that on my calculator, I get, strangely enough, 59,048. So what does that mean? That means that if I were to start with the number 2 and multiply it by 3 and do that 10 times and add up all of those numbers, it would add up to 59,048. Here's another example that uses the sigma notation that we saw in the last lesson. So here we have our formula. We have 1/4 times 3 raised to the k minus 1 power. Okay, and our first term is going to start with k equal to 4, and then our last term is going to be k equals to 12. So we need to figure out a couple things. We need to figure out and list what our a sub 1, our r, and our n are. So a sub 1 is going to be what I get when I plug 4 into this formula here. So a sub 1 is going to be 1/4 times 3 to the 4 minus 1 power. So what did I do? I took this stuff here in front of the sigma and I plugged in 4 for k. That's going to give me my first term. So that gives me 1/4 times 3 to the 3rd, or 1/4 times 27, okay, which is 6.75. So that's my first term. That's going to be my a sub 1. Now, this large number right here that's raised to a power, that's going to be my r. That's always going to be my common ratio. And now to find n, I'm going to do like I did with an arithmetic series, is I'm going to do 12 minus 4 and then plus 1. And that's going to give me the number of terms that I'll have. And actually, if that doesn't make too much sense to you, count on your fingers from 4 to 12, and you will end up with 9 numbers. So my n is going to be 9. So let's plug those into the formula, and I'll go ahead and write out the formula here. Times 1 minus r to the n over 1 minus r. So that's going to give me a sub 1 is 6.75 times 1 minus 3 to the 9th over 1 minus, and my r is 3. So that gives me 6.75 times 1 minus 19,683 over -2, and plugging that all into my calculator, I get 66,426.75. So that would be the sum of this geometric series. Now let's kind of do it a little bit backwards. So we have to find a sub 1 in a geometric series for which we know that the sum of the first 8 terms is 765. So we know that n equals 8, and we're given that our common ratio is 2. So using our formula, a sub 1 times 1 minus r to the n over 1 minus r. I'd suggest you write out the formula every time. If your teacher may not require that you memorize it, at least you'll be very familiar with it. And plugging in the values that we have, we know that for n equals 8, the sum is 765. A sub 1 is what we don't know, and then we have 1 minus r, which is 2 to the 8th power, over 1 minus 2. So that's going to give me, let's see, so plugging that into my calculator, I actually skipped a couple steps here. So this is going to give me a -1 on the bottom, so I'm going to multiply both sides by -1. So that gives me negative 765 equals a sub 1 times, and when I do 1 minus 2 to the 8th power, I get -255, and dividing both sides by a -255, I get a sub 1 equals 3. So in this lesson, we took a look at geometric sequences and series and learned a couple formulas. You may or may not have to memorize them, but really just you need to be able to know what a sub 1 is, what your n is, what your r is, and just plug them into the formula. Also, it's helpful to write what you don't know, what you're trying to find.